5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
This is About Space, America's return to space, with news and information on our U.S. space program. Is your host of About Space, David Denault.
Welcome and thanks for joining me today as we report about NASA advancing an existing technology to enable future space exploration of our solar system. I'll have a special report on space nuclear power and propulsion next on About Space Today. Are you ready to fly away on a dream vacation? For cruises and all-inclusive resort vacations, call D&D Cruise and Tours at 877-747-8631. That's 877-747-8631. And see us on Facebook, D&D Cruise and Tours, where your dreams become a reality. Welcome back. For years, our deep space missions have been powered by small nuclear reactors. But to sustain a moon base and to travel to Mars, more power will be needed. Here's an update on what NASA is developing to accomplish its goals.
NASA is advancing an existing technology to enable future space exploration of the solar system. With plans to expand human missions to Mars and science exploration of the outer planets, the need for reliable power becomes essential. Space-qualified nuclear reactors are one technology that can provide for safe and reliable power for many of these missions. Nuclear power in space is not new. A U.S. program was put into place that developed and flew the world's first space reactor. Before the reactor is turned on, that is, prior to fission starting, the reactor fuel is very safe and only mildly radioactive. A joint venture between NASA and the Department of Energy is underway to develop a new space reactor that meets a range of exploration missions. The reactor, called Kilopower, can deliver a range of 1 to 10 kilowatts of electricity. That is enough to power anything from one toaster to an entire household. Kilopower will be tested in the Nevada desert at the Nevada National Security Site. The test has a fissioning reactor deliver heat to Stirling converters. Each converter produces about 100 watts. The reactor uses well-established nuclear physics to self-regulate the fission reactions, and this feature eliminates the need for a complicated control system. The reactor uses nuclear fission to produce heat, which is delivered by heat pipes to power generators, known as Stirling converters. A radiator is used to keep the Stirling converters cool. A great deal remains to be done, but with the successful completion of the nuclear test in Nevada, NASA is coming ever closer to the reality of a space-qualified nuclear reactor. Over the coming years, the reliability and safety of Kilopower will be tested to assure that when the new era of space exploration begins, all systems will be a go.
And the Perseverance Mars 2020 rover, like its predecessors, has a small nuclear power system. Well, join me next Tuesday as we explore America's return to space and listen Fridays for America in Space with Rick Potluck from our Washington Bureau. And remember, invite your family and friends to listen to our podcast and have them follow us on Facebook at aboutspace.today. And to our many friends in the U.S. and around the globe, thank you for listening, and be safe during these wintry days. I'm David Denault, and this has been About Space Today.